Hello everyone, my name is Souhaila and I will be presenting to you our analysis on Web API structures and their data models. It's a work authored by me, Fabio De Lauro, and the professor Cesare Pautasso. We are all from the Software Institute at USI in Lugano, Switzerland. In this work, we performed a large-scale empirical study on Web APIs. A Web API can be small and simple, offering a small number of operations, as they can be very large that they cannot even be visualized in a presentation slide. The size of an API is an important factor that impacts the API's governance, the experience of developers with the API, also how much easy it is to learn it, and the service granularity. So in that work, we defined a set of metrics in order to measure an API on two different levels, on the level of its structure and its data model that describe the resources that are handled by the operations defined in the structure of the API. Our approach is based on analyzing Web APIs through their descriptions written in the OpenAPI Specification. So for building our dataset, we went to GitHub and we searched and downloaded more than 100,000 models. We deduplicated them, then we filtered the ones describing APIs that are handling in one of their endpoints some data of JSON media type. And at the end, we ended up by analyzing more than 30,000 models. This large number of OpenAPI specifications we gathered have been parsed and analyzed in order to answer a set of questions. First, how big are actually the APIs we're analyzing? The size of the API, in our case, is defined as both the size of its structure and the size of its data model, which leads us to a second question. Is there any relationship between the size of the API structures and their data models? Or in other words, if an API is so big and it offers a lot of operations, does it mean necessarily that its data model is also that large? Another question is mainly related to the data models of the APIs. Is there any reuse of data schemas within the same API? And finally, to avoid overgeneralization and see how the answers of the previous questions are affected by the API style, we segmented our dataset focused on each subset of APIs sharing the same structural style. We then performed the same analysis on each of the segments of the dataset. When we talk about the size of an API, we can receive a lot of answers depending on the metric we chose to measure it. Let's start by the size of the structures. OpenAPI descriptions of Web APIs contain all the needed details to extract and draw their tree structure. Based on this structure representation, we defined our size metrics. The first one is the number of paths, which are simply the number of paths listed in the original description of the API. The second one is the operations. This can be also extracted from the OpenAPI descriptions details. From these two metrics, we can compute a new metric, which is the number of operations per path per each API. Our fourth metric is the breadth. In the case of the API in the example, the breadth is equal to 1. It is defined as the number of nodes that are directly connected to the boot, which means also in that case that all the paths of this API start by the segment user. While we can see that in this API there is more diversity. The breadth of this API is equal to 5. Another metric is the depth, which is simply the maximum depth of the tree structure. And then, last but not least, the HTTP methods used in the API. In that case, we have usage of 5 different HTTP methods. Based on these metrics, we found that the majority of the APIs under study have less than 50 paths, and some few ones have more than 100 paths, going even up to 271 paths in the case of one API. And that same API uses actually only one method in all its operations, and its breadth is equal to 1. The breadth goes up to 80 in the case of some APIs, while the deepest tree have up to 80 nested nodes. Some APIs have endpoints using 8 different operations, and so using 8 different HTTP methods, with an average of more than 2 HTTP methods used per API. The operations of Web APIs handle resources of different data schemas. In our work, we extract these data models from the API's descriptions, keeping track of the relationships between the concepts and the operations where the data schemas are used to describe a request or a response in the OpenAPI models. Each class here represents a resource data schema, and the composition relations between them are depicted by these composition notations, and the arrows are connecting them to the operations, and they can show us where each data schema is actually used. So based on this way of seeing the API's data models, we define its size using the following metrics. First, we simply count the total number of schemas defined in the API model, and we also count the number of schemas that are actually used. From these models, I used schema as any schema that is reachable from one of the operations of the API. And from these two metrics, we can also compute the usage rate of each schema in a data model of an API. We found that most of the API's data models are composed of at least 3 defined schemas, and also most of them have 2 schemas that are used. However, in most of them, all of the defined schemas are actually used. The largest data model is composed of 580 defined schemas, where not even half of them are used. And the largest data model with a usage rate of 100% is composed of 386 schemas. Now that we measured the sizes of the API structures and their data models using the defined metrics, we can also answer the second question by looking at the correlations between the values of these metrics. Doing so, we found that the highest correlations are spotted between the number of defined schemas in the API model and the number of endpoints defining its structure, which can be perceived from the data points distribution in the plot. The next highest correlation is between the number of schemas that are actually used, not only defined in the model, and the number of paths. This can be simply explained by the fact that, actually, in the most of the APIs, most of the defined schemas are used. The third highest correlation is between the number of unique schemas defined or used and the breadth of an API structure. This result means that in the case of some APIs, the breadth can be actually a metric that reflects the diversity of resources type handled by the API. To answer the third question regarding the reuse of schemas within the same API, we defined new metrics that computes the number of reused schemas in a data model. From our presentation, these schemas can be spotted by finding the ones having more than an arrow connecting them to an operation. And we also defined the reuse rate metric, which reflects the number of reused schemas among the total used ones. One of the interesting results we found is that in the most of the APIs, there is at least one schema that is reused. Even in a case, the number of reused schemas was more than 150, and the reuse rate in some cases reaches 100%. We can also clearly see that the chance of reuse is highly correlated with the API's data model sizes, and it increases in the case of larger data models, while we can see a weak correlation between the size of the API structures and the data model's reuse. So to see how the previous results would change if we focus on a smaller subset of the dataset, we segmented the data by the structural styles of the APIs. We distinguish 5 styles: the read-only, which are the APIs that have only GET methods, and it is the largest segment. Then we have the RPC style, which are APIs allowing to write using POST method, the read and writes, the typical CRUD, and we put in a category we called REST, any other API using any other type of methods combinations. So we found that the APIs of read-only and RPC styles are more likely to be small, while the CRUD and REST are most common styles of structurally larger APIs. Regarding the data model sizes, we found that the APIs that have a more largest data model are the ones of a REST style, while the usage of schemas is almost similar proportions for all the styles we defined. And finally, to conclude, I would like to recapitulate the main points of this presentation. First, I put you in the context of the work, then I showed you the amount of data we analyzed to get answers about the API sizes, the correlations between the API structures and the data model sizes, about how much schemas are reused in the API's data models, and finally, if the size of each of the structures and the data models has something to do with the structural style of the API. And thank you for watching, and if you have any questions, feel free to reach us.